Okay, so today we're going to review decimal computation by solving some real-life problems. When I say computation, I mean one of four things: add, subtract, multiply, or divide. When we add and subtract decimals, we want to line up the decimal points. And if there's something missing, we'll annex zeros or add zeros and put the decimal point in the problem, and then we add or subtract like normal. However, when we multiply decimals, we want to forget about the decimals at first. Line up our numbers, multiply as usual, and then we count the number of significant digits behind the decimal point in the problem. And then we move our decimal back toward the left that many places, that many significant digits. When we divide decimals, we need to make, if our divisor is not a whole number, we need to make it a whole number by moving the decimal point to the right. Whatever we do outside, we do inside of the division, and then we just put the decimal point on top of up in the quotient exactly where it is, and then we can just divide like it's not there. Okay, you're going to be recording your answers on this slide, or if you're in class, you do have a paper copy, you can work on it on paper. And this next slide will be for homework, or if you're again in class, you can work on the back on paper. Okay, problem number 1. So you should have your recording sheet either on paper or your slide. Okay, so Brock, Kason, and Zach went to lunch at a local restaurant, tacos and burritos. Brock's total with tax was $5.98. Kason purchased a drink for $2.85 and 2 tacos for $1.42. Zachary had 3 burritos for $2.05 each. Find the total cost of their purchases. Also, if the cost is divided equally among the students, how much should each student pay? So we're going to find number 1 on our recording sheet. And let's see, we've got Brock, Kason, and Zach. And Brock his meal is $5.98. Kason got a drink, and I'm going to be looking for the total, so I'm going to be adding. So I can go ahead and add those two together, lining up my decimal points. And then with Kason, he has 2 tacos at $1.42 each. So I could multiply. I could add 142 and 142, but I could also multiply. When I do that, I want to forget about the decimal points. So I'm lining up my numbers and I multiply without any decimal points. 284. Then I go back and I count the significant digits behind the decimal point. 1, 2, and I'm going to start at the end of the number, and I'm going to go to the left 2 places for 2 significant digits, or siggy diggies. Okay, so far we've got this for the drink and Brock's meal. We've got Kason's tacos at $2.84. And then Zach gets 3 burritos at $2.05. I could add $2.05, or I could shortcut by multiplying. Forget about the decimal point when I multiply. Just line up the numbers and multiply, and then count the significant digits after the. So the siggy diggies are 2. So always start here at the end, and I'm going to move it to the left 2. So $6.15. And to get a total cost, I'm going to take all of that, lining up my decimal points. I don't have to annex zeros. Just put that decimal point in the answer and add it. And we have $17.82 is the total cost. Adding and multiplying. The other part of the question is if the boys share the total and split it evenly, how much would each boy pay? So here's our total. We're going to divide by the 3 boys. So $17.82 divided by 3. We're going to choose division. And so when we go to make our division, the first number always goes inside. Okay, if that helps. So I'm going to put that inside, and then the second number goes out in as the divisor. Okay, can I have decimals in the dividend, the den, in the den? So I've got it, and there's nothing out here, so I just put it on top where the quotient is, and I can forget about it. I can just divide like there's no decimal there. Okay, so 3 can't go into 1, but it can go into 17 5 times. That's going to be 15. And then I can, you know, dad, mom, sister, brother, Rover. So 15, subtract, I get 2. Bring down the 8. And I repeat. 3 goes into 28 9 times. That's 9 times 3 is 27. If I subtract, I get 1. I still have another number to come down. And repeat. 3 goes into 12 4 times. And then when I subtract, I have 0. So I'm at the end, and there it is. 594 for each person. Okay. So all that was for number 1. We did add, multiply, and divide. Okay, let's look at problem number 2. Lydia is a chef at the restaurant. To make her signature salsa, Lydia always adds 75 thousandths of an ounce of hot sauce to each salsa serving. How much hot sauce would she use in 8 servings of salsa? Okay, so first we have to figure out how do we write 75 thousandths? So we might need a review of place value. So we're going to take a look. We have our decimal point. We don't have anything. We don't have ones. But over on the right side, it starts with tenths, 100ths, 1,000ths, and so forth. So knowing this, when we write 75 thousandths, I want the 5 to end up in the thousandths column. So I'm going to need to annex a 0 here. So 0.075, and we read it 75 thousandths. Okay, so she puts this much hot sauce into each serving. So we want to know how many for 8. We could add this 8 times, or we could shortcut by multiplying. And I would choose multiply. Multiplying decimals, we forget about the decimal point. I'm going to forget about the zeros too for right now. I'll worry about that at the end. So what is 75 times 8? Okay, that's a little bit easier to look at. That's 600. Now I go back and I count how many Siggy Diggies are behind the decimal point. There are 3 in the problem. There are 3. So then I move 1, 2, 3 to the left, and I end up with 0.6 or 6/10 ounce of hot sauce. I could include these zeros. They are not significant anymore because nothing significant digit does not follow them. So you could say 600 thousandths if you wanted, if that makes more sense, or shorten it to 6/10. All right, number 3. So now we have a fastest taco making contest. Ava makes her taco in 12 and 4/10 seconds. Ella, we've got some more place value here. Ella took 12 and 14/100 seconds. Mariana made a taco in 12 and 26 thousandths seconds, and Takora finished in 12 and 3 thousandths seconds. What was the combined total of the fastest taco making times? So I need to translate these. You know, you might want to refer to your place value chart here. But combined total, that kind of tells me that I'm going to add them. So I need to translate them first. So Ava, 12 and 4/10 would look like this. Ella, 12 and 14/100. Mariana, 12 and 26 thousandths. Okay, notice that 0. I had to get the 6 to the thousandths. And then Takora, 12 and 3 thousandths. 2 zeros annexed here. Now, when I go to add them, I've lined up my decimal point, and I can add some zeros in where there's nothing, just so I don't miss anything and I line everything up correctly. And I just add it, put my decimal where it is, and I'm sorry, the total was almost 49 seconds, so less than a minute for all of them. Okay, number 4. Briley earns an hourly wage of $13.85 managing the restaurant. If Briley works 32 hours this week, how much will she earn? Okay, so we could add 1385 32 times, but shortcut, we can multiply the two numbers and to get our total. Again, we want to forget about the decimal point when we multiply. So however you want to multiply this, whether you use the standard algorithm or you do an area box model, I'm going to use the standard algorithm. And I have 10, 16, or I'm sorry, 10, carry the 1, 16 plus 1 is 17, carry the 1, 6 plus 1 is 7, 2. Now I'm going down here, I need to add a 0 for place value, and then continue the same thing. 5 times 3 is 15, carry the 1, 24 plus 1 is 25, carry the 2, 9 plus 2 is 11, carry the 1, 3 and 1 is 4, and then I add these two. Then the final step is I go back and I count the significant digits in the problem. There are 2, so I move, always going left, I move back 2, and I have $443.20 will be her total. And that was multiplying. Okay, number 5. For number 5, Emma and Haley are making fabric tablecloths to cover the small rectangular tables. Each table measures 25 and 42 hundredths meters squared across the top. That's the area. If the width of one table is 4/10 meters, what must be the length of one tabletop? Okay, so this gives us actually the area and it gives us the width. It wants the length. So, and it's rectangular. So area is length times width, or base times height. Given the area and the width, to get the length, I'm going to have to do the opposite of multiplication. I'm going to have to divide. So I'm going to take 25 and 42 hundredths and divide that by 4/10. Now here's a problem. I've got decimals in both the divisor and in the den. Okay, first I'm going to start out here with the divisor. I cannot have a decimal there, so I need to make this a whole number. I can make it a whole number by moving it over 1 to the right. If I do that, I can do that as long as I do the exact same thing in the den, right here in the dividend. So I would move this 1 to the right, and it would look like this. Okay, and then I simply take that decimal point and put it on top, quotient, and then forget about it. And then I can just divide like they're just regular numbers. Okay, so when I do my long division, okay, I'm going to see that I have some leftovers here. Okay, we're not going to have a remainder. We've already started a decimal here. So what we can do is we can add zeros till the cows come home. So we can add zeros, continue dividing, and then that is 20, and then I get 0. So I only had to add 1 0 there. And so here is the length, 63 and 55 hundredths meters is the length of one tabletop. Just meters and meters. See, this is meters squared because it's the area. Okay, you try 6 and 7. Oh, wait, before we do that, there is a retro arcade in the restaurant. There's 1 quarter to play a game. How many games could you play with a $5 bill? Lots of ways to solve this. You could mentally think $1 is 4 quarters. And so $5 times the 4 quarters is 20. You could simply divide. You could say $5 is 500 cents divided by 25 is also 20. Either way, you've got 25 cents, 20 quarters in a $5 bill, which will give us 20 games. Okay, now you're going to give 6 and 7 a try, and then you will check the answers. You will check your answers. There also is a cool down form. And for homework, so there's a cool down form that will be linked here. And for homework, I want you to create your own taco burrito word problem involving decimals and computation. I also want you to solve it. And that's where you are going to put it either on this slide right here, or if you have a paper copy, then you are just going to, you can write that on the back. Okay. All right, we will check the answers for the last two. So you can pause and work that out, or you can take a look, and then you're going to do your cool down, and you have a small homework assignment. And this is all going to help us review for the SCA on Wednesday. And if you're ready to check 6 and 7, there you go. Okay, tomorrow we'll be doing decimals in a donut shop.